use the filter circuit for that. Okay, the filter circuit, what it does, see, one of the important thing with respect to the filter circuit is that filter circuit is the circuit which should remove the unwanted AC part. See, which will remove the unwanted AC part, we got the pure DC output which is across your load. Okay, so filter circuit, definition of filter circuit is that filter circuit is the circuit which should remove the unwanted AC part and gives the pure DC output across your output of your circuit. Okay, this is the thing with respect to filter. One sentence I'm telling you what do you mean by filter. So filter is the device which should remove the unwanted AC part and we got the near about pure DC output. That is the thing of this slide. Did you understand this slide? Please tell me. Please tell me, did you understand anything related to it? Problem any? Prajakta with Patak, did you understand this?
Yes, sir. Yes.
Did you understand?
Yes, sir.
Okay. See, we have seen why we need of the filter. See, we doesn't do the filter only as we have to be accept and tell the same thing. This is not thing, because this is our need. See, why the particular thing we have to be used, why we the need of the filter, that we have to be seen here. See, we know that rectifier is nothing but it is the device which should convert the AC voltage into the pulsating DC voltage, right? This is the output of your rectifier, right? So rectifier indicate that it have, see, it have this indicate that positive half cycle, this indicate that positive half cycle, right? So it is a fully rectifier output, right? Why it is called as fully rectifier? See, when we have to use the fully half rectifier, in that case output is coming only alternate half cycle. Okay, this, see, either this is the output of your folio center type or folio bridge type. It doesn't need of it. We have to be considered this output is the folio bridge type or center type, means it is a folio configuration output. Okay, so whatever the output coming across it, that should be a rectified output, that should be applied to the filter circuit, right? See, filter circuit means what? See, there are normally two combination, inductor and capacitor, that are used for the purpose of filtering the AC component. Now see, what is the use of inductor and capacitor? See, inductor is the device which should passes on. See, the concept of inductor is that, or whatever the things with respect to inductor is that, inductor is the device which should passes only the DC signal, only DC signal allowed by the inductor. Okay, with respect to capacitor, I'm telling you, capacitor is the device which should passes only the AC signal. Okay, these two concepts are used for the filtering purposes. Okay, accordingly, see, we have to be used for the filtration purposes. See, now this is only block diagram, that's why I am telling some extra knowledge for you. See, we have applying the, this is pulsating DC to the, this is a filter circuit. Okay, means pulsating DC input is applied to the filter circuit. Filter circuit does the filtration work. Filtration work is as like as in a Maraठी, चहा जसा असतो ना आपण एखाद्या काळी तो घेतो, same way it is done, means only remaining water of tea is coming across it. Same way, only the whatever the DC component, that only coming with respect to output. Okay, this is the DC. We just consider here only the things related to the block diagram. We have seen the detail in a further session. Now see, one of the important thing with respect to the ripple. What do you mean by ripple? Now see, ripple indicate that the definition of ripple is that, see, when we have passing the pulsating AC voltage, which should be converted as the DC. Okay, so see, this pulsating DC component indicate that it has some of the AC components. So the undesirable AC component is called as ripple. Did you understand what do you mean by ripple? Ripple indicate that the undesirable AC component, which should be in content of the rectifier output, that undesirable AC component is called as a ripple. Okay, this is the definition of ripple. Okay, so see, need of the filter. So we require the DC, but whatever the output coming from your rectifier, that is a pulsating DC. So to convert the pulsating DC into the pure DC, we have to be need of the filter circuit. This is the concept of the filter, or this is the need of the filter. Did you understand this slide? Please tell me. Please give me reply.
Yes, sir.
Okay. If not understand, please tell me. This is not understanding us. I'm repeating. Okay. Now see. One minute. Madam asking related to. So we have seen the detailed diagram of the filter. Okay, means how the particular filter should be attached with respect to output of your rectifier. Now see, this is the 230 volt. See, 230 volt AC voltage is which is coming from your transformer. See, this is the primary side of the transformer. Okay, primary side indicate that it have high winding compared to the secondary side. Why? Because it is a primary side. 230 volt is coming across here. Secondary, there should be near about the, we have to be considered as a 12 volt or the 24 volt AC, right? So transformer is the device which should convert the AC voltage into the AC, but it should be step up or step down according to our need. Okay, see, so consider as a 230 voltage applied here, 12 volt is coming across your output. Okay, one another thing with respect to this, is there connection between primary to secondary? Please tell me. Direct, is there direct connection between primary to the secondary?
No, sir.
Right, tell me which type of the linkage with respect to it. One of the word force that should be called as flux linkage. Is it correct? Please
Yes,
tell.
sir.
Please see, the connection between primary to secondary is not direct. There should be a flux linkage between primary to secondary. There should be flux linkage with respect to your winding. So that's why primary have high winding, and secondary have low winding. Okay. So see, accordingly there are two half cycle with respect to AC, that is positive half cycle and second is negative half cycle, right? So during this positive half cycle, what we have to do, during this first positive half cycle, this positive is coming across here. Okay, positive voltage is coming across here, this negative voltage is coming across here. Okay, so see, during first, plus is here, minus is here, right? So there are two diodes, here is one diode, here is one diode. Consider that first positive conductive diode is considered as a D1 diode. So this should be conducted as a diode D1. So diode D1 is conducted. So during that time, positive voltage is coming across here. Okay. Now see, this combination is called as CLC, or it should be called as pi type of filter, because this combination is as like as mathematical pi. See, CLC is as like as mathematical pi. This is the one of the mostly used filter type configuration, because it gives the very less, means 0.01% ripple in your output of the circuit. Okay, see, so what happened, whatever the output coming across here, there are three elements: capacitor, inductor, capacitor. These three elements used for the filtration purpose. Okay, so see, when this output is coming, consider as a, it is a ripple indicate that it is a pulsating DC. Okay, pulsating DC indicate that it has some of the noise indicate that AC signal. Okay, we know that the concept of the inductor and the capacitor, we know that capacitor is the device which should passes only the AC. Okay, so if it contains some of the AC part, that should be bypassed by this capacitor, and that should be going towards the ground. Is it understand? Okay, so see, only DC part is coming across here. Okay, we know that inductor is the devices which should passes only the DC signal. So all of the DC signals should be passed over here, right? So see, this inductor, this capacitor is not the perfect devices, right? So if it contains, see, if it contains some AC ripple remaining, it should be passes over this C2, and we got the near about it is 99% pure DC output across your load. This is the detailed diagram of the filter with respect to positive. Now see second half cycle. See, now see, we know that AC out half cycle, that is positive and negative. Now see, negative half cycle is coming here minus, here plus. Okay, so due to that plus voltage, now see, plus time this diode is conducted, at a time minus is, see, plus is here, minus is here. Due to that minus, this diode is conducted, so negative is coming across here. Okay, this is in a first half cycle. Now see second half cycle, minus is coming here, plus is coming here. Okay, due to that plus voltage, diode, this diode is considered as a diode D2, right? It conducted, so positive voltage is coming across here. At the same time, minus is coming across here. Same. Now see this diode, cathode is here, so that's why it conducted, so output is coming minus across your ground. Okay, now positive voltage is coming same way, either your positive half cycle or negative half cycle, at the same time positive voltage is coming across here. So due to that positive voltage, again this capacitor filter out the whatever the pulsating component, it again that should be grounded. Then if it contain whatever the DC, that should be passed by this inductor, because inductor have property that it only passes the DC signal. Then if it contains some AC component, it should be bypassed by this capacitor. So we got near about 99% DC output, right? This is the detailed thing of the filter circuit. Okay, any problem, please tell me. Did you understand the detailed thing of the filter? Just this is the just introduction. I'm directly written the CLC, because for the example purposes you have got the detailed things. See, did you understand concept of filter, what it does actual?
Yes, sir.
Okay. Now we know that with respect to inductor and with respect to capacitor, we mathematically know, we mathematically see how it should be, not passing particular voltage, not passing the particular thing, that we have to be seen with respect to the mathematically, right? I'm already told you, inductor is the device which should passes only the DC signal, right? And capacitor is the devices which only passes the AC signal. How it is possible mathematically, that we have seen. Okay, the filter circuit uses the component whose reactance is depend on the frequency of the signal. See, in case of filter circuit, we use the two components, that is inductor and capacitor, right? So inductor and capacitor, that are the component which reactance should be depend on the whatever the value of your frequency of the signal, right? Means it should be varied with respect to the frequency of the signal, right? So that's why we have to be seen the analysis of the inductor with respect to applying the particular AC as well as DC voltage. Means performance of, means we know that we have seen the thing related to the performance of inductor. Means it should be theoretically. We know that theoretically inductor does not work with respect to the AC. Theoretically, we know that capacitor does not work with respect to the DC. Okay, these are the some things. I'm repeat the same thing. See, AC component means AC. For the AC, there should not be use of inductor. See, for the AC, there should not be use of inductor. For the DC, there should not be use of capacitor. That are the two things. Why it is, we have discussed here. Okay, inductor indicate that the reactance offered by inductor is given by, we know that one of the equation with respect to inductor, XL is equal to, means inductive reactance, which is equal to 2 pi FL. Okay, XL equal to 2 pi FL, right? For the we just consider this thing with respect to DC as well as AC. Okay, for the DC signal, we have seen that for the DC signal, we know that frequency, DC indicated, it doesn't have any frequency. Why? Because it should not be changes with respect to time. Okay, so frequency of the DC signal, it is a 0. Okay, so 0 indicate that F is 0. So 2 pi L, anyhow it doesn't matter it. So anything with respect to 0, it is a 0. So XL value, that must be 0. Okay, why? Because F is 0, XL equal to 0, right? So what it indicate that for the DC signal, see, for the DC signal, whatever the XL, the inductive reactance of that particular inductor, it is a 0. Okay, so it that is inductor allowed DC signal pass through it. Why it is? Because whatever the reactance coming with respect to DC, with respect to this, it is a zero, right? Okay, did you understand this thing? Please tell me how it is true. Did you understand? I'm repeat the same thing. See, the reactance offered by the inductor is given by, we know that one of the equation, inductive reactance, it is nothing but a 2 pi fn. Okay, now for that equation, we know that for the DC indicate that it doesn't have the positive negative cycle, the value whatever that should not be changed. Okay, so value of f is 0 into anything, it is a 0. Okay, so the XL value which is equal to 0, what it indicate that if we have applied the DC signal, inductor doesn't give any reactance or it doesn't have any opposition, right? So it indicates that inductor allows the DC signal passing through it. Did you understand the things? Please tell me.
Yes, sir.
Okay, now we have seen with respect to the AC signal. Okay, we have seen the same thing with respect to DC. Now see, we have seen the AC signal, right? So AC signal indicate that frequency of AC, either it is a 50 hertz, in case of America it is a 60 hertz. Okay, now told we know that frequency of AC, it is not zero, that is more than zero, right? So frequency is not equal to 0. So what it may indicate that XL equal to, see, XL equal to 2 pi. 2 pi F indicate that 50, consider as a 50. So what it indicate that XL have some of the value. Okay, did you understand? See, when we have to be consider F have some value, indicate that 2 pi into frequency consider as a 50, right? 2 pi into 100 pi, and L have some value. Okay, so XL have some of the value. Is it understand? Please tell me, is it understand you? Whatever I'm telling you with respect to this point. See, for AC signal, okay, frequency not equal to 0, not equal to 0 indicate that frequency have some value. Okay, we consider as a frequency of 50 value. Okay, 50 into 2 pi, it is nothing but 100 pi. Inductor have consider as a one value, consider as. So XL have 100 pi. Okay, XL have 100 pi indicate that it has some value. Okay, so what it indicate that XL is not equal to 0. Is that correct? Please tell me. XL has some value, 100 pi or 1 pi, consider. So it has some of the value. So XL is not equal to 0. See, did you understand this equation? Please tell me.
Yes, sir.
Okay, XL not equal to 0, right? So what it indicate that for the AC signal, see, for the AC signal, inductor does not it passes, right? Why it is? Because when AC signal is applied to the inductor, it gives the sum of the value. So it indicates that opposition, right? So that is the inductor block the AC signal. Why? Because it have opposition from your device. Okay, inductor. Okay, why it is? Because XL value is not 0, it has some value, so it indicate that inductor block the AC signal. Okay, because it does not passes over this, because it has some value. Now we have seen the things related to the capacitor. We have seen the all the things with respect to inductor. We know that in our earlier equation we have seen that inductor is the device which will be passes only DC signal. How we have to be seen with respect to the particular equation. Okay, so we have discussed the thing with respect to the capacitor. We know that reactance, see, Xc is nothing but a capacitive reactance. Capacitive reactance which is equal to 1 upon 2 pi Fc. Okay, this is the value of the capacitive reactance, right? For the DC, we discussed this term with respect to DC as well as AC. For the DC signal, we have seen that we know that DC indicate that it have frequency 0, right? So 0 frequency indicate that 2 pi into 0 into something. It indicate that 1 by 0, right? 1 by 0, right? 1 by 0 indicate that it is nothing but a infinity. We doesn't define it. Okay, so it is a 0. Sorry, frequency 0 indicate that 1 by 0 indicate that infinite. Okay, so what it indicate that for the DC signal, see, for the DC signal have the capacitor infinite opposition. So it indicate that there should be blocking of the DC signal by this capacitor. Did you understand this thing? I'm again repeat. See, capacitor, the capacitors or capacitive reactance offered by the capacitor, it indicates that Xc is equal to 1 upon 2 pi Fc. This is the equation for it. Okay. For that purposes, what we have to do? Frequency for DC, it is a 0. So 2 pi into all of the things, it is nothing but a 0. Okay. 1 by 0 indicate that infinity. So what it indicate that capacitive reactors have the infinite impedance. Okay, in case of your DC, right? So what it indicate that DC is not passed by this capacitor, DC is blocked by this capacitor. Due to this equation we have to be known. हे लक्षात येत आहे का? Please tell me according to this equation. Did you understand the things? If not, which thing is not understand? Please tell me. हे क्वेश्चन लक्षात येत आहे का? प्लीज रिप्लाय द्या.
Yes, sir.
Okay. So X is equal to infinity. What it indicate that if we have to be use the capacitor, see, we have to be use the capacitor, we have passes the DC signal, so it should not be passed over output. Why it is? Because we have seen the thing X is equal to 1 upon 2 pi Fc, and in case of DC it have 0 frequency, so 1 by 0 indicate that infinity. It indicate that there is a there should be highest blockage from the when we apply the AC signal with respect to this type of. Okay, so now we have to be sorry for that, we discussing the DC signal, right? So DC signal indicate that when we are applying the DC signal, we are applying the DC signal to the capacitor. In that case, what happen? DC signal have 0 frequency. See, DC signal have 0 frequency. So whatever the output Xc output is coming, that is a infinite. Infinite indicate that whatever the opposition coming from your capacitor, in case of your DC, that is a maximum, that is a infinity. That's why DC signal is not passed by this capacitor. Okay, now see for the AC signal, we know that frequency, see how the frequency which is not equal to 0, right? If it is considered as a 50, see some value. Okay, so it is a 50 indicate that 1 by 2 pi into 50 into 1, consider, right? So consider as a 2 pi into 50, 100 pi, 1 divided by 100 pi, right? Whatever the value coming from Xc, it is a very less, that is, point not, right? That is the value coming with respect to Xc, that is very low reactance, right? So what it indicate that capacitor offers very low reactance with respect to your AC, right? That's why I'm telling you, for the inductor there should be DC passes over it. For the capacitor there should be AC passes over it. Okay, these are the two things which we have seen in this equation. Okay, did you understand this thing? Please tell me. See, there are two statements. Inductor should be connected in a that is the important thing. How that connected? See, for the purpose of the filtration, we must connect an inductor that is in a series of your whatever the configuration. In case of your capacitor, whatever the capacitor used across it, that must be capacitor with respect to the output, right? That is the thing how we have to be connected and how it should be act as a filter. See, only capacitor act as a filter only when it should be connected with respect to the parallel with respect to your load, and inductor that should be connected in series with respect to your load. Only that time it should be act as like as filter. Okay, any problem related to this slide? Please tell me. Did you understand this slide?
Yes, sir.
Okay. Now we have details here. See, when we have to be C filter, these are the part of this session. There are initially explained, which just not explain, but which are the type of the filter. That is C indicate that capacitor type of filter. Then L indicate that inductor type of filter. Then LC, inductor and capacitor type of filter. Then we have seen the third type, that is CLC, that is pi type of filter. Okay, these are the some of the types of filter. Why the different filter should be designed? See, the reason behind it is whatever the performance of your output. See, whatever the performance of your output, that should be enhancing, as we have to be use the added configuration of your filter, right? That's why we have to be use the added configuration of filter. Initially we have seen basic type of filter, right? So which are the basic type of filter? C type of filter, it is also called as capacitor type of filter. What is the input and output of these configurations? Capacitor indicate that for that configuration we have to be use the as a load capacitor. Okay, means this capacitor, whatever the used across it, that should be load is nothing but output of this configuration. This indicate that rectifier configuration. Okay, I have explained this diagram. See this for the we have seen the performance of sub capacitor type of filter. To see the performance of capacitor filter, we have to be start up with the whatever the input with respect to it. Okay, see above figure shows that, the circuit diagram of the capacitor type of the filter. Okay, in this diagram 230 volt AC supply is applied to the input of this configuration. Okay, see in this diagram something wrong. Please tell me which is wrong with respect to it. For the understanding purpose, we have to be understand this thing, but it is wrong. Which is the wrong? Please tell me. If you see in this diagram, actually this is considerable purpose, it is not wrong, but it is wrong. See, whatever the primary winding, it is a less, whatever the secondary winding, it is a more. It is not acceptable. See, but this is for diagram purpose, we have to be accepted, because in case of primary there should be higher winding. See, there should be higher winding because it should be connected to the 230 volt and it should have secondary have less winding. Okay, so we have applying the 230 volt to the primary of the transformer. Accordingly, there should be secondary generated if we have to be considered as a 12 volt 12 volt AC or the 24 AC with respect to output of this transformer. Okay, secondary of this transformer. Okay, see whatever the output, that is secondary of this transformer, this is which type of the transformer? Please tell me which type of this transformer. Tell me which type of this transformer. Step down, but see type of this transformer, it is also called as center tap type of the transformer, because we have to be use the center tap for it. This is the wire, central wire connected, that's why it is called as center tap type of the transformer. Okay, so we have applied the voltage, that is 230 volt across it. Initially we have to be considered as a positive half cycle. Okay, positive half cycle of the transformer. Okay, due to that positive, see, due to that positive half cycle, what happened? Plus is, see, with respect to this center tap transformer, I may explain you. Plus is here during first positive half cycle, plus is here, minus is here, again below plus is here, minus is here. Okay, so plus voltage is coming across diode D1, minus voltage is coming across diode D2. So we know that the diode which have positive voltage, it is nothing but a forward bias of the particular diode. So that's diode D1 is forward biases, right? So due to that forward biases of this diode, whatever the voltage that should be coming across your load. Okay, that voltage is coming across due to it, means positive half cycle is coming across your load. We know that whatever the output coming, it is contain AC as well as DC part. Why? Because rectified output. Okay, we know that the property of the capacitor, it only passes the AC signal. So whatever the component, it contain AC plus DC, only AC component should be gone through the negative, that is ground. Okay, so we got whatever the component, that is DC component across your load. But see, if we have to use only capacitor, it is not the this device not the actual device, means it does not This is the pure 100% ripple free output. It has some of the disadvantages. That's why whatever the output coming, it contains some of the ripple again remaining. So we got the output, it contains some of the ripple. See, we have applied the 230 volt, right? 230 voltage applied. According we got the whatever the output, that is a this is the output of your rectifier. See, this is the output of your rectifier. Okay, rectifier. See, if here we have to use the capacitor, it should be charge and discharge. Okay, filtration indicate it should be charge and discharge. See, initially it should be charges from C, start up with A. It should be charges over the B point. Okay, it should be charges over the B point. After all B point, it should be fully charged. Okay, this capacitor should be fully charged. Okay, fully charged indicate that it should be turned off. After all, it's trying to discharge. Okay, it trying to the discharge up to the level of the C. Okay, it should be discharges up to the level of C up to this C level. Again, second voltage coming from your diode D2, that is a positive. So again, it start charging up to the level of D, right? Up to the level of D. What happened? Again, it should be fully charged. Again, it should start to the discharge. It should be again discharges up to the level of E, right? So after all E, there should be again another dot, that is the diode is on. Again, it should be charged over towards the F level. Okay, after all F level, it should be fully charged. Again, it should be discharges. This cycle remain happen. Okay, so due to that, see, due to that charging and discharging, it produces the some content of the ripple. It doesn't reduces the 100% ripple in the output of your rectifier. So whatever the ripple content in case of your output of your rectifier, that should be reduced by the C type of filter. It should be used as some applications where we have to be accept the small type of the noise or unwanted signal. Okay, these are the things with respect to the this type of the configuration. Okay, this is the thing with respect to the capacitor type of the filter. Did you understand the C type, that is capacitor type of the filter? Please tell me. If any student doesn't have the doesn't give the knowledge about the particular site, then he asks me repeat it. I'm repeat it. Please tell me. मराठी सांगतो खरं तर दुसऱ्याला कळालं मी का थांबू असं नाही. तुम्हाला नसेल समजलं तर तुम्ही सुद्धा विचारू शकता मला. कुणालाही कळलं नसेल त्याने स्वतःहून सांगायचे की सर मला समजलं नाही, रिपीट इट. ओके, सांगा प्लीज टेल मी. डिड यू अंडरस्टँड धिस स्लाइड ऑर नॉट? म्हणजे पर्टिक्युलर कोणाचं तर नाव घेतोय म्हणजे त्यांनी यसच म्हणावं हे अपेक्षित नसतं. सर समजलं नाही हे पण अपेक्षित असू शकतं, लक्षात घ्या. Okay, please tell me, Nilesh Babar, did you understand this thing? Sonal Lohar,
Yes, sir.
did you understand this C type of filter?
Yes, sir.
Okay. Whatever thing I can explain, that is here. Okay, detail. See, all of the PPT as well as the all of the thing that should be on your teaching diary. Okay, upper part of teaching diary. We have discussed the another type of the filter, that is series inductor type of the filter. See, 5 we have to be use the different thing, right? Inductor as well as capacitor. Now see, I just up to 10 minutes I am still related to the inductor type of the filter. Now see, why the inductor type of filter connected in series with the load? Tell me. We just discussed the thing related to it. Why inductor connected in series and the capacitor connected in a parallel with respect to your output of your rectifier? Please tell me. Because these are the assumption. Till now we have seen last slide. See the slides. Here we have to see that inductor should be connected, Inductor should be connected in a series with load. Capacitor should be connected in a parallel with load. This is the assumption that must be implemented. Only whatever the device should be act as an filter, right? That's why we have to be connected in a particular. Either it is a series, either it is a parallel. See, we have discussed the thing with respect to the inductor type of the filter. Okay. See, inductor, we know that inductor is the device's proper, repeatedly telling you the property of the inductor. Inductor is the device which should passes only the DC signal. Okay. So property of the passing of the DC signal that should be used for the inductor type of the filter. Okay. See, whatever the output, coming with respect to this device, that is a rectifier. Means before that, means before the use of the filtration, it have again converted as an filter. Means sorry, rectified. Means whatever the AC voltage that should be applied to the transformer, it sends over the diode configuration. It should be fully bridge or fully center type configuration. So output of that fully bridge or fully center, that should be coming across here. That's why rectifier output is applied across your input of inductor type of the filter, right? So whatever the output coming across your inductive type of filter, uh, see, whatever the input coming from your rectifier, that should be applied to the inductor type of the filter. We know that the property of the inductor, which is the property of inductor, it should passes only the DC signal. So whatever the rectifier output, it contains AC as well as DC part. Okay. So inductor, what it does, inductor only passes the DC signal, right? So whatever the output across your output of the inductive type of filter, that is near about pure DC. Okay. DC output is coming across here, but whatever the device used across here, that is inductor, it is not a pure, or whatever the output coming, that is not a pure DC. It contains some of the noise, because only one device is used over here, and it is a not ideal. One of the important ideal indicate that we know that student indicate one thing related to the student must be study mode in always. Okay, this is the thing with respect to study student, but there are some of the barrier or some of the reason this is not act as like a student. This will be happen same way. This will be happen because there are so many things with respect to your natural thing or some other things that affect the performance of students. Same way, see, this is the inductor, it is not pure or it is not ideal. Okay, so we know that inductor must passes the signal which should only the DC signal, but it has some of the lacuna, or it has some of the problem. That's why it contains some of the AC components. So whatever the output coming up across inductor, that also some content ripple. Okay, so these are the things with respect to the inductor type of the filter. Okay, normally the inductive reactance is given by Xc to pi FL. Oh, actually it is XL to pi FL. Okay, inductive reactance, right? So whatever the value of the inductive reactance, we know that XL is equal to 2 pi FL. We have already proved the things with respect to inductor, that XL is equal to 2 pi FL. So for the DC signal, see, for the DC signal, XL value which is equal to 0. So what it indicates that it gives the 0 reactance for the DC, right? When we have applied the AC signal, in that case, it gives the highest value, right? Highest value indicate that no AC signal should be passed over it. So for that purposes, rectifier devices, whatever used across here, it should passes the only DC signal, but it is not the ideal devices. So it contains some ripple remaining. That is the thing with respect to the inductor type of the filter. Any problem with respect to this slide? And another, see, one of the important thing which we have not seen with respect to inductor is that property of inductor. See, property of inductor is that it opposes to the change of current, right? it opposes to the change of current. That property also used for the filtration purposes, right? Means it have property that म्हणजे in a Marathi one thing जे दिलेल्या वाटेने चालले लक्षात घ्या, स्पेसिफाईड वेगळे असं काय करायचं नाही, राईट? सो in case of your this type of the configuration, it doesn't allow to change, right? So these are the property of the inductor, right? This property is for the particular case, and it should give the near about the pure DC. Okay, means inductor two property which should be used here. One property indicate that it should passes only the DC signal. Why that done? Because it have property that it opposes to the change of current. Okay, these are the thing with respect to the inductor. कंटाळा असाल तर आपण स्टॉप करूया. इफ यू हॅव प्रॉब्लेम, बिकॉज 6वं लेक्चर आहे सकाळपासून तुमच्यासाठी. आणि ओके, अटेंडन्स द्या.
हॅलो सर,
हा बोला.
असाइनमेंट जेवढ्या झाल्या तेवढ्या सबमिट करायचं का?
हा, लिहिलं तर बरं होईल, कारण परत अभ्यासाला वेळ मिळेल तुम्हाला, असं माझं म्हणणं होतं. तुम्हाला मी बहुतेक म्हणजे जेवढे असाइनमेंट तुमच्या टीचिंग डायरी दिलेत ना, त्यातले कोणते नंबरचे सिलेक्ट करायचे लिहायचे ते मी सांगितलंय. आहे का ते शीट तुमच्याकडे?
हो सर आहे.
हा, ते आणि तेवढेच सॉल्व्ह करा, आणि ते काम आधीच करा. का सांगतोय की परत तुम्हाला अभ्यासाला वेळ मिळावा, हे माझं म्हणणं आहे. कारण कसं होतंय, नॉर्मली 30 मार्च तुमची एक्झामची डेट आहे म्हणतात. एक 4-5 दिवस मे बी झाली तर होईल, शक्यता कमी आहे पुढे मागवायची. त्यामुळे आता जे राईटअप वर्क आहे ना, ते करून टाका तुम्ही आताच. ओके, सगळ्याच त्यामुळे लिहून घ्या. वाटल्यास तर फॉर दॅट पर्पज यू हॅव टू गिव्ह हेल्प ऑफ SY स्टुडंट. Why? Because they have already started the write-up of the particular assignment. Because for that purpose you don't go on more time. Okay, your friend of SY, they have also same assignment. Okay, for also same experiment. Okay, so all of the experiment as well as all of the assignment you have to write down now only. Why? Because there should be more load in this same also. पहिली गोष्ट लक्षात घ्या, आत्ता लोड यायचं कारण काय आहे की तुम्हाला ऍक्च्युअली ऍडमिशन होऊन 2 महिने पण झाले असतील आणखी. लक्षात घ्या, आणि लगेच एक्झाम आली. ओके, लोड जास्त असतो या सेमला तुम्हाला, डायरेक्ट सेकंडरीच्या मुलांना खरं तर अनएक्सेप्टेबल लोड असतो. त्यामुळं हे जे वर्क आहे ना, हे आधीच उरकून घ्यायचं. अभ्यासाला एक 8-10 दिवस जरी मिळले तरी बाद झाले. ओके, त्यामुळे हे माझं सब्जेक्टचं नाही म्हणत मी, सगळ्यांच्या सब्जेक्टचा राईटअप तुम्ही परफॉर्म करा. ओके, आणि कुणाची, माझी सांगत नाही, कुणाची टेस्ट देत असताना नॉर्मली जास्तीत जास्त मार्क पाडावा, कारण की त्याचे मार्क तुमच्या इंटरनल मार्कमध्ये कन्सिडर केले जातात. ओके, आणखीन कुणाला काय प्रॉब्लेम? कुणाला काही प्रॉब्लेम आहे का सांगा, रिलेटेड टू द स्टडी किंवा एखाद्या समजत. एक लक्षात घ्या, जर माझा पॉईंट कुणाला काही समजला नाही तर कुणीही, म्हणजे समजा बाकीचे कोणी बोलत नाहीये, मी का बोलू असं नाही करायचं सर, मला हे समजलं, रिपीट करा. थोडं एखाद दुसरं लेक्चर जास्त जाईल, लक्षात घ्या, पण समजायला पाहिजे. कारण काय आहे की इलेक्ट्रिकल ब्रँचचा बेस आहे हा इलेक्ट्रॉनिक्स. लक्षात घ्या, ऍक्च्युअली ज्यावेळेस कुठल्याही ब्रँच नव्हत्या ना, इलेक्ट्रिकल, सिव्हिल आणि मेकॅनिकल ह्या 3च ब्रँच होत्या. त्यापासून इलेक्ट्रॉनिक्स असेल, बाकीच्या सगळ्या ब्रँच, कॉम्प्युटर असेल बाहेर, त्यापासून तयार झालेले आहेत. लक्षात घ्या, तो बेस आहे तुमचा हे इलेक्ट्रॉनिक्स वगैरे, त्यामुळे ते तुम्हाला पाहिजे. ओके, काय प्रॉब्लेम असला तर मला विचार जावं, वाटल्यास तर असं समोर विचारता येत नसेल तर पर्सनली कॉल करून विचारत जावा, काय प्रॉब्लेम असेल सांगत जावा. ओके ओके, स्टॉप करायचं आपण. प्लीज. ओके ओके, सॉरी, अटेंडन्स राहिलाय ना. ओके, रोल नंबर 1 B SYB, 2 3 5
Present.
ओके, 5 प्रेझेंट,
present.
6 7
Present, sir.
8
Present.
9
Present, sir.
10
Present, sir.
11 12
Yes, sir.
13 14
Present, sir.
15, 16,
Present, sir.
17, 18,
Yes, sir.
19, 20,
Yes, sir.
21, 22,
Yes, sir.
23, 24, 25, 26, 27, 28,
Yes, sir.
28, yes, 29, 30,
Yes, sir.
31, 32, 33,
Present, sir.
34, 35,
Present, sir.
36, 37, 38. Absent number 3, 6, 11, 12, 13, 15, 17, 19, 21, 23, 24, 25, 26, 27, 29, 30, 32, 34, 36, 37, 38. Okay.
26, sir.
26. Okay. Again.
12 present.
30.
Okay.
30, sir.
30.
Sir, 12 present.
12 present. Okay. Hmm? 6. Okay. A चे कोण आहेत का प्रेझेंट?
Yes, sir. 6.
ओनली
Four.
रोल नंबर एक मिनिट एस वाय ए वाय बी रोल नंबर 1 प्रेझेंट नंबर सांगा 1 to 10 मधले रोल नंबर 1
6.
6 बर
4.
Yes.
6 4 आणखीन 1 to 10 मधले 4 आणि 6 फक्त 10 to 20 10 to 20
A division चे 2च आहेत, sir.
okay 4 and 6 present okay if you have any problem please ask me okay stop now